no real reason that a circle is 360 degrees. We just kind of say that and we base everything from there. So it doesn't work as well when you're trying to do lots of different algebra techniques with it because degrees is kind of an arbitrary thing. Radian measure is what's considered a real number measurement. And so when we are looking at a circle, so in a circle, a radian is the size of an angle where the radius and arc length are equal. So let me show you what I mean by that. So if I took a circle, the radius, we all know what a radius is, correct? It's the distance from the center out to the edge of the circle. So whatever length that is. However far I would have to spin, so the distance on the outside of the circle, the arc length, was equal to the radius, that would form an angle of 1 radian. So this is my radius, and this is arc length. We use that as S. So if R and S are equal, that is 1 radian in our circle. Did you guys kind of understand what I mean by a radian?
What do you mean by R equal?
So R is the radius, arc length is the distance on the outside of the circle. So I'm saying however big you'd have to make that angle so that the distance on the outside of the circle was the same as the radius. That would be equal to 1 radian. All right. So to find the size of our angle, all we really have to do is divide S and R. So your angle is the arc length divided by the radius. So, if I said a central angle theta in a circle of radius 3 cuts off an arc length 6 centimeters, what is the radian measure of theta? So if you think about theta is in a circle, that's the angle. I'm telling you the radius is 3 and the arc length, this distance on the outside of my circle, is 6. So if I want to find my angle, all we have to do is the arc length divided by the radius. So my arc length is 6 centimeters. My radius is 3 centimeters, so how big is this angle? 2. What happens to those centimeters? Cancels. So this is why when we're talking about radians, it doesn't have a unit, because the arc length and the radius have the same unit, and so that cancels. You can write radians if you want. You do not have to. But from now on, anytime I see an angle without a unit, I am assuming I'm talking about radians. So if you want 30 degrees, you better label it degrees. Okay, if you're talking about 30 radians, then you just put 30 with no label. All right. So we need to be able to go back and forth between these two measurements. If we're going to have two different ways of measuring an angle, we need to be able to convert between them, right? So let's think about how we could do that. So I just told you that an angle in radians is S divided by R. So in a whole circle, your arc length would be all the way around. What's the complete distance around the outside of a circle? Well, that's your degrees. Think about circumference, distance around the outside of a circle. Does anybody remember that formula? That's area. Two pi r. So if you go all the way around the circle, that's the circumference. So that's 2 pi r. All right. So let's convert this. So my S would be 2 pi r. If you go all the way around the circle, how many degrees is that? So 360 degrees would have to equal 2 pi r over r. But what happens to those r's? So 360 degrees is equal to 2 pi. So 180 degrees is equal to pi. This is what we need to know. So I kind of showed you why it is what it is. You're not going to have to necessarily do that conversion again, but what you need to know to go back and forth between degrees and radians. 180 degrees is equal to pi radians. That will be our conversion from now on. Let's look at a problem. I want to change 45 degrees into radians. So we have done conversions before, right? We set up those little ratios, like we're going between minutes and seconds. We would say, 1 minute is 60 seconds, and set up that kind of ratio. If I have 45 degrees, I want to change it into radians. I want my degrees to cancel, so that would have to be on the bottom. What is my conversion between degrees and radians? What did we just write down? 180 degrees is equal to pi radians. Or you could say 360 is equal to 2 pi. It'll work the same way. So I'm going to say 180 degrees is equivalent to pi radians. So I'm just going to multiply by pi over 180. You need to be a little bit cautious using your calculator for this. If you type pi into your calculator, it's going to give you a decimal. And with radians, we typically leave the pi in our answer. So if you're going to use your calculator, you want to do 45 over 180, but don't type the pi in. And then we just write this as a fraction. So 45 over 180 is 0.25 or 1/4. So I would write that as pi over 4. Those degrees canceled, we're in radians. You can write the word radians, but it's unnecessary. Anytime we don't have a...
Well, why'd you only put the 4 underneath the pi?
Okay. So if you multiply, that's like 45 pi. So you reduce this and said 1/4. So you could write it as 1 pi over 4, or just leave off the 1. Other questions, sir? So let's change 450 degrees to radians. So what would I multiply by? Pi over 180, we want the degrees to cancel, so it goes on the bottom. So all you really have to do on your calculator is 450 over 180, and then change that to a fraction. So what does that give us? So you could say 2.5 pi if you wanted, or 5 pi over 2, either way. Right. Sometimes we may have one that's not as pretty. Like if I give you a decimal, negative 78.4 degrees, I want to change that to radians. This time I said to round to the nearest hundredth. Since I already have a decimal and I'm telling you to go ahead and round your answer, let's go ahead and type in the pi as well. So we want to cancel the degrees, so again we just multiply by pi over 180. And I'm just going to type all of this in my calculator. Negative 78.4 times pi divided by 180. Nearest hundredth is 2 decimal places, so I get negative 1.37. So I don't want you to think that radians have to have a pi on the answer. They usually do, but you could certainly multiply out the pi and get a decimal. So we could see it either way.
We didn't put the pi in the answer because we used it. Right?
Yes. If you put the pi in the calculator, then you don't write it on your answer. If you don't type the pi in your calculator, it's still there on your final answer. Okay. Let's go the other way. So if I asked you to change pi over 6 into degrees. So pi over 6 is radians. What would I multiply by? (180 over pi. All that happens is you flip that fraction. We have radians, we want the radians to cancel, so we just put the radians on the bottom. So my pi's drop out. I'm left with 180 divided by 6, 30. Now, if I write that, I'm wrong. Why?
You didn't put the degrees on.
Yes, you have to have your degree sum. Okay, here's your problem. Change 4 pi over 3 into degrees. So what do you multiply by this time?
4 divided by, well, 180 divided by pi.
So my pi's cancel. So 4 times 180 divided by 3 equals 240 degrees. Everybody get that?
I didn't do the 4 times 180. I did
4 thirds
times 180.
That works too. What if I gave you, let's just say negative 4.5. If I gave you that, is that degrees or radians? radians. I didn't put a degree symbol, so it's radians. So if I wanted this in degrees, what would you have to multiply by?
80 divided by 5.
You want degrees so that degrees go on top. All right, so a couple ways you could write this answer. 4.5 times, negative 4.5 times 180 is negative 810 over pi degrees. You could also go ahead and divide that out and get a decimal. So that is 257.83 degrees. So you kind of have that option there. If it's not a pretty one, you can multiply the pi out if you would like. All right. Any questions so far? Okay, so I have something for you.
We just stretch.
Okay.
So we can-
So in this chapter, we're going to start using what's called the unit circle. It's really just another trick to help us with our sines and cosines. You know, we've been doing the hand trick, and that's working really, really well for some of you. This is just another tool that we have. When I talk about a unit circle, this is a circle with a radius of 1. So unit meaning 1 for our radius. So if we put degrees on here, these are our common degree measurements. So this would be 0 degrees. What would this line represent?
90.
This would be 180, and this would be 270. And what do you think these other three represent?
30,
30.
45, 60.
Those common angles that we were doing on our hand. Okay, so over here, this is like my reference angle. So this would be a reference angle of 30. So what's 180 minus 30? This one is a reference angle of 45. So 180 minus 45. Here's my reference angle of 60. So 180 minus 60 is 120. Notice as you go around the circle, your degrees should be getting larger. All right, in the third quadrant, if I'm looking at this angle, that's a reference angle of 30. So you'd have to do 180 plus 30, which is 210. Next, 180 plus 45. 225. 180 plus 60. 240. How do we get the angles in our fourth quadrant?
360 minus.
So 360 minus 30 is 330. 360 minus 45 is 315. 360 minus 60 is 300. So as you go around, these angles get larger. These are all of my angles with a reference angle of 30. And then as you go out, these all have a reference angle of 45. And these have a reference angle of 60. So the circle is nice and symmetrical. Okay, it's dealing with our reference angles. All right, any questions how I got those degree measures? You do have the option 0 degrees. What would be another thing we could call that one? Yeah, I don't care. You can put 0, you can put 360. They are equivalent. All right, so next I want to do the radian measure for each of these angles. So if we think about our radian, we just talked about converting. If you have degrees and you want radians, so if I have 30 degrees, how would I change that into radians?
Is it divided by pi?
Flip it though. We want
Pi.
radians, so put the radians on
Pi.
top. Pi over 180. So what you really have to do is 30 over 180 and turn that into a fraction. And what's that give us? 1/6. So this would be pi over 6 in radian form. I guess I didn't do my 0. What's 0 times pi over 180? 0 times anything is still 0. So this is 0 radians. Or 360. If you did 360 times pi over 180, what does that give you?
2.
So you could call this 0 or 2 pi, all the way around the circle. So for my 45, if you do 45 times pi over 180, so 45 over 180 as a fraction gives us 1/4. So this would be pi over 4. And then 60. So 60 times pi over 180. I think you're ahead of me one. 60 over 180 is 1/3, so this would be pi over 3. And if you at 90 times pi over 180 is pi over 2. Does everyone understand how I got those radian measures? Look at your denominators as you go up. 6, 4, 3, 2. What's happening to those? Yeah.
That's why I said pi over 2. I thought it was going by 2s.
It does. So the pattern isn't consistent, but at least it's getting smaller. 6, 4, 3, 2. We skipped the 5, but it does get smaller as we go up. Okay. So we need to keep going with these. There are lots of ways we can get this. Let's try, if we just keep doing what we've been doing. Okay, so 120. So 120 times pi over 180. So you do 120 divided by 180 as a fraction, and that gives us 2 pi over 3. So 135 times pi over 180. So everybody know how to get these numbers on your calculator? Basically just taking that divided by 1.
Getting like the 3 and the 2 from.
This?
Yeah. No, like the 2, that for the 2 and then the other one.
This?
Yeah.
I'm just working out, so if you do 120 times pi over 180. So 120 over 180 is 2/3.
Oh, okay.
So that's 2 pi over
That's
3.
how y'all getting that. I kept putting in my calculator, I kept getting a decimal.
Don't put in the pi.
Alright.
And then you can hit math number 1 to write it as a fraction. So for 150, you would do 150 divided by 180. And then if you hit math number 1, it changes its fraction form. And we put our pi with it. So it's 5 pi over 6. At 180, what's 180 degrees equal to? Pi. Okay. So look at this. Do you notice anything? What about our denominators?
Same on both sides.
Same. And look, the yellow lines were my reference angles of 30, and both of those denominators are 6. The orange lines have my reference angle of 45, and both of those are over 4. My greens had a reference angle of 60, and both of those are over 3. So we could probably make some predictions. At 210, what do you think my denominator is going to be? 6. Okay. So let's talk about some other patterns here. Think about when we did reference angles. You know, for the degrees, we did 180 minus 30 and got 150. We could also do the same thing in radians. You could do pi minus pi over 6. So this is like 6 pi over 6 minus 1 pi over 6 is 5 pi over 6. So the same patterns that we've done before would still work. So in the third quadrant, we would add. So you would have to add your pi over 6. Or you could keep converting. If you do 210 times pi over 180, you get 7 pi over 6. All right, if you do 225 times pi over 180, what do we get? Pi over 4.
Okay, how'd you get
The
pi
5.
over 4?
I did 225 times pi over 180. So on your calculator, do 225 divided by 180, and then hit math number 1. So for 240, 240 times pi over 180 gives us 270 times pi over 180 All right, let's go ahead and finish this, and then we'll look at some other patterns. So if we keep going around, 300 times pi over 180. So if you do 300 over 180, and math number 1 to get it in a fraction, 5 pi over 3, at 315 times pi over 180. And 330 times pi over 180. Okay. So we filled out this whole circle. And you could do this on your own just by converting. Basically all you're doing is dividing your degrees by 180 and sticking a pi with it. Now, if you pay attention though, there are tons and tons of patterns. In the first quadrant, the numerator was just pi, right? In the second quadrant, 5 over 6, 3 over 4, 2 over 3. How are the top and bottom related? They're 1 apart. The top is 1 smaller than the bottom. And we know what the bottoms are going to be because the 30s, whoops. My 30s are all over 6, so I knew all those would have a denominator of 6. All my 45s are going to have a denominator of 4. All my 60s have a denominator of 3. In the third quadrant, how are the top and bottom related?
Top's bigger, probably.
Yeah, the top is 1 bigger. And in the fourth, can you figure out the pattern there?
Doesn't it go like 2, 3, 5? On the top.
It's times 2 minus 1.
Okay. You might, I'm not sure if I completely understand what you're saying. I'm not saying you're wrong. I'm just not on the same page. If you take the bottom, 6 times 2 is 12, minus 1 is 11. 4 times 2 is 8, minus 1 is 7. 3 times 2 is 6, minus 1 is 5. So in the fourth quadrant, it's double minus 1. So these are some tricks that we are going to use. Helping recognize some of these patterns will help us out in the future. So we will be looking at this circle numerous times, kind of like when we first did the hand trick and filled out that table. We did it several times. So this is something that we are going to be working towards just to help us get a better understanding of these trig functions and going back and forth between degrees and radians. Are there any questions there? Okay, so here is my next problem for us. I want to find the sine of pi over 6. Now we've been doing questions like this for a long time, but I would say find the sine of 30 degrees. I'm just changing it. I said pi over 6. So when I see pi over 6 in radians, that's like what degree measure? 30. So if we think about our hand trick, sine of 30 degrees is 1/2. So I can ask this answer in degrees or radians now.
Okay, that threw me off.
Okay.
When you said, I got what you meant by how you got 1/2, but like, what does the divided by 6 do?
Oh, so this was just the radian measure. So pi over 6, we know from our circle, is the same thing as 30 degrees. So this is just another way of me asking, what is the sine of 30 degrees? All right, what if I said, find the cosine of 3 pi over 4? So we did quadrants and reference angles when I asked you these, right? So my quadrant, and you can look at your circle, but we can recognize patterns. When the top is 1 less, what quadrant did that happen in? Quadrant 2. Is cosine positive or negative in the second? Negative, so I know my answer will be a negative. Then we do our reference angle. Now you can go through and convert these into degrees if you want, but actually if you're in radians, reference angle is really easy. You just ignore the top. So it's just pi over the bottom. So my reference angle is pi over 4, which I know is like what degree measure? So, what is the cosine of 45 degrees? You get negative radical 2 over 2.
So why did we ignore the 3
That
pi
just,
divided by 4?
that 3 pi over 4 told me it was in quadrant 2. Okay, and then I just needed the reference angle part, which was just the pi over 4. So it's kind of like if you converted that into degrees, whoops. If you convert it into degrees at the beginning, you would look at the whole thing to figure out the quadrant, and then you would subtract from 180 to get the reference angle. So that's essentially what we did. Is that one okay? What if I said find the tangent of 5 pi over 3? So with these, we need quadrants and reference angles. So 5 pi over 3, what quadrant would that be in? And I use my quadrant to decide positive or negative. Is tangent positive or negative in the fourth? Reference angle. When you have these radians, the reference angle is really easy. You just ignore the top. So it's just pi over 3.
60 degrees.
So what is the tangent of 60? So my answer is negative radical 3. All right. Questions here? I think that is where I want to stop. So here is the assignment. We will have class time tomorrow, maybe not a full class period, but a good chunk of your class to work on this. So it will not be due until Thursday.